Welcome students. Today we'll start with design example on column splicing. Design a column splice for ISHB 350 at 72.4 kg per meter subjected to factored loads. So the loads are axial load 600 kilonewtons, 500 kilonewton meter bending moment and 150 kilonewton horizontal force. Use M20 property class 5.6 volts. Design and sketch the details. So from steel tables, note down the following properties. So ISHB 350 at 72.4 kg, H is 350 height. So I have drawn this diagram. So this is H. So this dimension is width of the flange. This is thickness of web. This is thickness of flange. So note down all the things H, B, TW and TF. I have got these values from steel tables. Axial load, so these are factored loads directly given. Axial load 600 kilonewtons, moment 60, horizontal shear 150. So remember, I am going to use these for flange design, flange splice, and this for web splice. So shear I am using for web splice design. So step 1, design of flange splice. Okay, now in the problem it is given that ends are machined or smoothed or milled or grinded. All this means the same. It means 50% of the loads are taken by a flange and 50% by direct action. So 50% of loads are taken by flange. So load on flange is equal to 50 by 100 of 600 kilonewtons. So you get 300 kilonewtons. Now remember, this 300 kilonewton load is shared by two flanges. So I will provide a flange plate here and a flange plate here. So load on each flange is equal to 300 divided by 2. So 150 kilonewtons. So this is the load on each flange. Next, convert bending moment into axial loads, and that is given by M by H. So moment is 50 kilonewton meters divided by H. H is the height of the section, 0.35. So you get the answer 142.8 kilonewtons. Therefore, total load on each flange is equal to 150 this plus 142.8. So you have the final answer 292.8 kilonewtons. Now for rolled section, for rolled steel, Fy is equal to 250. Therefore area of flange splice is equal to load divided by Fy into 1.1. So load divided by Fy divided by gamma m naught, partial safety factor. So here load is 292.8 into 10 raised to 3 divided by Fy 250 divided by 1.1. So you have the answer 1288.8 mm square. Now, as I said, this width of the flange splice should be same as width of the I section. So here my B value is fixed. Provide width of flange splice equal to width of flange of I section. Therefore, B is equal to 250. B into 2 is 1288. And I can write here this is equal to B into T. Therefore, thickness T is equal to area 1258 1288 divided by B. B is 250. So you have the answer 5.16, say 6. Therefore, provide flange splice of size 250 by 6 mm. Now design of flange splice is completed. Now let us go with design of web splice. Second step, design of web splice. Yield strength of web, it is given by clause 8.4.1 of IS 800. So what value it gives is, for web, strength is given by FYW by root 3, where FYW is 250 divided by root 3. So strength of the web is 144.3 newtons per mm square. Therefore, area of web splice is equal to load divided by strength. So load is 150 into 10 raised to 3. So 150 is horizontal shear. I am designing for horizontal shear, divided by 144.3 characteristic strength of web. So that gives me an answer 1039.5 mm square. Now here our width cannot be finalized. So what we do is, minimum thickness of web splice should be 5. I will try 6 mm thick web splice. Therefore, B is equal to area divided by thickness, 1039.5 divided by 6. So it gives me value 173, say 175. So provide web splice of size 175 by 6. Now here there is one problem issue. You have finalized thickness first T and then you have found out B. So how much should be, or what should be the range of this width of the web splice? Look at the diagram here. You are providing web splice here. This dimension H already I know, and that is given as 350. Next, H minus TF. So this much is the width. So here there is some rounding portion. So assume this to be 50 mm, this to be 50 mm. So roughly this width should be H minus 100, not greater than that. If you are getting value greater than that, so what you do is simply increase the thickness. Increase the thickness, your B will reduce. Now design of connections, third step. So under that, first bolt value. For bolt value, shearing strength. For bolt value, I am going to use M20 property class 5.6 bolts. But shearing strength, assume bolts are in single shear and shear plane intersects threads. Therefore, Nn is equal to 1, Ns is equal to 0. Now directly calculate design shear strength. VDSB is equal to 1 upon 1.25 Fu for bolt material, 500 by root 3 into number of shear planes Nn into cross sectional area of bolt at threads. So 0.78 into pi by 4 into dia square plus 0. Ns is 0. So you have the value 56.6 kilonewtons. Next, bearing strength. So to find, before you find bearing strength, find out Fu for plate material, that is 410. Fu for bolt material 500. D is 20. D naught is 22. Edge distance E is 1.7 D naught. So you have the answer 37.4, say 40 mm. Next, pitch distance P is 2.5 D. 2.5 into 20, you have 50 mm. So pitch at 50 is finalized. So before you start with all the calculations, first find out KB. So KB is, there are three values, E by 3 P naught or everything. So find out all those values. So you have answer 0.606, 0.507, 1.22 and 1.0. These are the four values of KB. Least value is this 0.507. So calculate VDPD, and that is given by 1.25, 2.5 KB. KB is 0.507. D diameter of bolt 20. T thickness of the plate, that is 6 mm into 410 for plate material. So solving all these, you get 49.88 kilonewtons. Therefore bolt value is 49.88 kilonewtons. So next step is design of connections. First, for flange splice, load is 292.8 kilonewtons. Already I have calculated. So therefore number of bolts is load divided by bolt value. 292.8 divided by 49.8. You have 6 number of bolts. Next, for web splice, load is 150 kilonewtons, horizontal shear divided by bolt value 49.8. You have 3. Approximate it to next round figure. So these are the connection details. Now I have to sketch the details. So let us start with the sketches now. Suppose this is an I section. So this is ISHB 350. So this dimension is 350, height h. Now I am going to provide flange plate here and on this face. Before you provide flange plate, start with bolts. So first bolt from here at edge, pitch, pitch and at edge your plate finishes. So this is how you will provide bolts. This line indicates the bolt lines. Now provide web plate. So web plate is provided here. 3 number of bolts, 3 on each. Say 1 2 3, 1 2 3. So for web plate or flange plate I have got 6 number of bolts. So 1 2 3 4 5 6 on each side. So if I have to take a view in this direction, I am going to view in this direction. So what I will see is width B. Next, this joint is seen as dotted line. Next, this edge of the plate is seen here. This edge is seen here. So this much, all this portion is web splice, sorry, flange splice. Now 3 bolts. So at the center will be web. Here like this. At the center will be web. Now what you have to do is this bolt in this line provide here and here. Whatever bolts you are getting on each side. If you want, you can show here. Say this is an I section. On this side, equal to width of the I section is web splice, sorry, flange splice, and at the web here, this I am going to provide it like this. This dimension is 175. So you have to write all the details. So this is flange splice 250 by 6. So this is web splice 175 by 6. Write the details and complete the sketch. Thank you.